A new cold fusion device just dropped. Let's have a look. This new cold fusion device comes from an Indian company by name Hylenr. They just made a demonstration of their device at a conference a few days ago. LENR is an acronym for Low Energy Nuclear Reactions, and it's what's colloquially known as cold fusion. Here you see the demonstration of their device. If I understand correctly, this is a comparison of two probes, two different materials and vacuum, which are supplied with hydrogen. The one on the left is a control without nuclear fusion, and the one on the right does nuclear fusion, also they say. The reading on the top is the power that goes in on both sides. As you can see, it's pretty much the same. And this reading down here, that's the heat that's produced at the surface of the materials. As you can see, the one on the right is clearly warmer than the one on the left. They claim that this demonstrates that they can create energy from nuclear fusion. The hydrogen nuclei, they say, fuse to form helium, and that releases energy which heats the material. Here is the co-CEO of the company.
We are just using pure hydrogen, 99.99 pure percentile hydrogen, enabling fusion. Output is excess heat. So this is the world's first in terms of excess heat generation by anybody in the world.
I've spent a lot of time looking at what the LENR people are doing, and my impression is most of them are neither stupid nor scammers. They're serious, but not always particularly great scientists. And yes, I'm a little skeptical about this company's claims. Before I explain why, I need to tell you a little bit about the context. Normal hot nuclear fusion, like the one which goes on in the sun, requires extremely high temperatures and pressures. You need those to push atomic nuclei into each other against the repulsion from their positive electric charges. In cold fusion, that barrier is supposed to be overcome by the chemical properties of some sort of material, usually palladium. What the cold fusion people do is to take that material, supply it with some light nuclei, often hydrogen, and then hope that they'll fuse. One of the reasons they've dropped the term cold fusion is that actually they do this at like 300 or 400 degrees Celsius or so. I'd call that very well done and not cold, but I guess compared to the center of the sun, it's indeed cold. Why do they need this temperature? I don't know, and they don't know either, but the fact that they do need to warm the material makes it very difficult to figure out whether any net power has been produced, and that's also the problem with this demonstration. The easiest way to demonstrate that nuclear fusion took place would be to actually measure the helium nuclei that were supposedly produced. They seem to not have done that. Now, to be fair, that's not all that easy because it's not a lot of helium and you'd need rather expensive equipment to track that down. It's easier to just measure the temperature. The problem with just measuring the temperature is the following. They pump hydrogen into a vacuum chamber with two different materials. Hydrogen is the smallest atom of all, and it likes to infiltrate pretty much all materials. If it does so, it'll slightly alter the lattice structure. This process is known as hydrogenation, and here it comes. It can release energy. As Wikipedia explains, hydrogenation is a chemical reaction between molecular hydrogen and another compound or element, usually in the presence of a catalyst such as nickel, palladium, or platinum. And hydrogenation takes place only at very high temperatures, which explains why the cold fusion people like to work at high temperatures and with nickel and palladium. The issue is now that when a material absorbs hydrogen, that can release energy because the lattice structure becomes energetically more favorable, and that can lead to heating. How much it does that depends on the material, which can very plausibly explain the differences in the measurements. What happens with the hydrogen? I'm not sure, actually. If the material just continued absorbing hydrogen, it'd become saturated at some point and the process would stop. So either they're not telling us the whole story, or, well, let me just say, I try to avoid electric discharges anywhere near those machines. What this means is that if they were to try and convert the heat that they produce back into electric power, it'd always be less than what goes in. This device is basically an electric heating, and a very expensive one at that. So I don't think this is a scam. My impression is that these guys are serious about what they're doing, and it's not impossible that it could work. For one thing, we do know that cold fusion actually happens sometimes, and you can buy these devices. It's just that they don't produce energy, they produce neutrons. These machines work by shooting a beam of deuterium ions, that's a hydrogen isotope, into a metal, for example, titanium. At first, the beam just deposits a lot of deuterium in the metal, but when the metal is full of deuterium, some of these nuclei fuse, and that spits out neutrons. Here's an example of such a device from Sandia Labs, which they call the Neutristor. It's cold fusion in the sense that the material evidently lowers the required temperature and pressure, but it still doesn't create net energy because it still doesn't happen often enough. Just exactly why this happens, no one really knows, because calculating electron energy bands in materials is a computationally extremely hard problem. It's one of the problems that they want to put on a quantum computer. So, I'd say that in lack of theoretical studies, it makes sense to just try it out. That said, I think that before claiming they're doing nuclear fusion, they should consult some chemists to find out if not maybe there's a more mundane explanation. If you want to revolutionize the world with your new clean energy solution, then maybe start with brushing up your physics and maths at brilliant.org. All courses on Brilliant have interactive visualizations and come with follow-up questions. I found it to be very effective to learn something new. It really gives you a feeling for what's going on and helps you build general problem-solving skills. They cover a large variety of topics in science, computer science and maths, from general scientific thinking to dedicated courses on differential equations or large language models. And they're adding new courses each month. It's a fast and easy way to learn, and you can do it whenever and wherever you have the time. I even have my own course on Brilliant. That's an introduction to quantum mechanics. It'll help you understand what a wave function is and what the difference is between superpositions and entanglement. It also covers interference, the uncertainty principle, and Bell's theorem. And after that, you can continue maybe with their course on quantum computing or differential equations. Sounds good? I hope it does. You can try Brilliant yourself for free if you use my link brilliant.org/Sabine. That way you'll get to try out everything Brilliant has to offer for full 30 days. And you'll get 20% off the annual premium subscription. So go and give it a try. I'm sure you won't regret it. Thanks for watching. See you tomorrow.